Ever wonder how something so small and sweet could shape the entire world? From the endless fields of towering sugarcane to the cold farmlands where sugar beets grow beneath the soil, every crystal of sugar begins its journey through fire, steam, and precision. Machines roar, steam rises, and raw nature transforms into pure white perfection. It's more than sweetness, it's centuries of innovation, empire, and science boiled down into one simple grain. The story of sugar is the story of energy, obsession, and taste itself.
It's in your coffee every morning, your favorite soda, your desserts, and probably half of the products sitting quietly in your kitchen right now. Sugar. Sweet, addictive, and nearly impossible to escape. The average person in the United States consumes around 80 pounds of it every year, which means more than a pound of sugar every single week. Yet few ever stop to think about where those tiny white crystals actually come from. They may all look the same, but they originate from two entirely different plants, processed through methods that are far more intricate and fascinating than most imagine. What lies ahead isn't just a story about agriculture, it's a tale of human ingenuity, chemistry, and the relentless pursuit of sweetness. It's the story of how we learn to extract pure sucrose from two completely opposite worlds, a tall tropical grass and a hardy root vegetable. Together, they drive an industry that refines over 100 million tons of sugar every single year. The astonishing part isn't that we can make sugar from plants, it's that whether it comes from a humid cane field in Brazil or a frosty beet farm in Minnesota, the final result is identical: pure, colorless sucrose crystals. Today, we're diving deep into how these two crops satisfy humanity's sweet craving, and why understanding how sugar is made might just change how you look at that innocent white bag sitting in your pantry. For more than 1,000 years, sugar has been one of the driving forces of civilization. It shaped trade routes, fueled economies, and even built empires. Its history begins with sugarcane, which first grew in New Guinea around 8000 BC. It took countless generations to discover how to extract and crystallize it into the white grains we use today. Sugarcane, despite its name, isn't a tree or bamboo. It's a tall grass that can grow nearly 20 feet high, with thick, jointed stalks filled with sugary juice. Sugarcane isn't planted from seeds. Instead, farmers cut mature stalks into sections called sets and plant them directly in the soil. Each segment sprouts new shoots, effectively cloning the parent plant. When harvest season arrives, it's a race against time. In some regions, workers still slice through cane fields by hand with machetes, a back-breaking job that has changed little over centuries. But in large-scale operations, giant harvesters roar across the fields, cutting, stripping, and loading up to 300 tons of cane per hour. Speed matters, because once cut, sugarcane begins to lose its sugar content immediately. To preserve its sweetness, it must reach the mill within 24 hours. At the sugar mill, the real transformation begins. The cane is washed, chopped, and fed into enormous steel rollers, machines that look like industrial pasta makers on a massive scale. These crushers squeeze out every drop of juice, leaving behind a dry, fibrous residue called bagasse. But nothing goes to waste here. That leftover bagasse is burned as fuel to power the mill's boilers, producing the steam and electricity that run the entire facility. Many sugar mills are fully energy self-sufficient, and some even sell excess electricity back to local grids. The freshly extracted juice doesn't look like sugar at all. It's dark, murky, and filled with impurities. The next step is purification. The juice is heated and treated with lime to neutralize acids and help separate out unwanted organic materials. Once clarified, it moves into a series of massive evaporators where heat carefully removes water, turning the liquid into a thick syrup. Then comes one of the most crucial moments: crystallization. In huge vacuum pans, the syrup is heated and stirred under controlled pressure until sugar crystals begin to form. This mixture of syrup and crystals, called massacute, is spun in giant centrifuges rotating nearly 1,800 times per minute. The spinning separates the crystals from the remaining syrup, which becomes molasses, a dense, dark liquid that has its own uses in baking, rum production, and animal feed. The raw sugar crystals that remain are dried, cooled, and ready for refining.
During this time, factories operate non-stop, 24 hours a day, to handle the entire season's harvest before the beets spoil. Not all sugar ends up in kitchen jars. A significant portion goes into industrial food manufacturing, soft drinks, candies, baked goods, and processed foods. Even the byproducts find purpose. Molasses sweetens rum, enriches animal feed, and suppresses dust on rural roads. Bagasse, the fibrous leftover from cane crushing, fuels boilers, generates renewable electricity, and can even be transformed into biodegradable materials or paper. The sugar industry has faced criticism for its environmental footprint, but it's also evolving rapidly. Many modern mills are energy positive, producing more electricity than they use, designed for higher sugar yields or lower water needs, pushing sustainability even further. Whether born from the steamy cane fields of the tropics or the frozen farmlands of the north, every grain of sugar represents months of cultivation, precise chemistry, and human innovation. The spoonful you stir into your coffee carries a story that spans continents and centuries.